Hi, this is our engineering ethics project on the ethical question of whether or not you should disclose a bridge fault to the public, and using a neural network to answer that question. So, here's a little background and clarification to our project. First of all, to define our project. Our project is creating a neural network to answer an ethical question. The question that it answers is whether or not you, the user, should disclose a bridge fault to the public. It is important to note that our question does not ask if a bridge fault should be disclosed to the public by someone. It also is not asking whether or not the information should be disclosed. It is only asking if the user should disclose the information to the public. Disclosing information like this is usually a last resort, as it may cause mass hysteria and panic that is oftentimes not the desired outcome. Therefore, as you can see in our results, it is very unlikely for someone to disclose a bridge fault to the public.
Each of the 26 questions held weight when determining the most appropriate course of action. However, the significance of each question varied greatly. To start, the questions denoted in the red text were the questions that had the greatest significance. As you can see, are you knowledgeable about bridges is the first question that is asked, and it is a deterministic question, being that if the user answers no, then no other inputs are observed, and the correct course of action is that you do not disclose the bridge fault to the public. The questions denoted in the blue text are the questions to be observed following the red texted questions. Lastly, the questions highlighted in yellow denote those questions that are highly dependent upon another. For each of the 100 scenarios generated, the 26 questions were answered using various if statements to allow for multiple questions to be dependent upon one another. After filling 26 columns in a 100 by 27 matrix, we logically determined targets for each of the generated scenarios. When doing so, we started by observing the answer to the questions that we believed should be weighted the most heavily. After deciding each of the most appropriate courses of action for each scenario, we were then able to input the function and its targets into MATLAB. The first time that we created the neural network, the accuracy of the neural network was 64.3% when running through the testing set. During the validation part of the network, the accuracy of the neural network was 78.6%, and the overall accuracy of the neural network was 91.1%. While that number is high, the testing and validation percentages were not all that high. The number of hidden neurons was 10. To increase the percentages in all categories, we went back through the scenarios and tried to see if we were answering the questions correctly. After changing a few answers to the scenarios and changing the number of hidden neuron layers from 10 to 5, we received better results from the neural network. The validation set accuracy was 100%, and the test set was 92.9%, giving the overall neural network an accuracy of 98.9% as seen in the confusion matrix.
This is our neural network. Instead of outputting a percentage of whether they should tell the public or not, we are outputting a 0 or a 1, and that is because of this line of code right here. If it is below a 0.49, it will output a 0, and if it is above a 0.5, it will output a 1. Now I will demonstrate how to input a set of 10 scenarios that we have created in Excel. The output that we have determined for each of these scenarios should be a 0, as in they should not tell the public. As you can see, the neural network has determined that in all of these scenarios, they should not tell the public, giving the neural network a 100% accuracy for this data set.